Hey, okay, so today is May 26th, and we have now not less than, it's about 30 minutes before we need to finish today's daily question. So, today's daily question, I already picked the description earlier today. So, it's a median question, and it is number 150. So it got 17, almost 18 upvote, but also got 500 downvote. So I'm not sure if that means good or not. So it's probably okay. Um, but it's a 150 and it's a median. So I think it's something like very basic for you to practice and you have to know, I think. And also, yeah, I checked. Uh, this question is recently used by Amazon 7 times, Google 5 times, LinkedIn 4 times, and Microsoft twice. So, and all four are big companies. So, I don't know. So, maybe this is worth for us to take a look to see what's today's question and how do we solve it. So, anyway, let's get started. So, today's question is evaluate reverse Polish notation. So evaluate the value of an arithmetic expression in reverse Polish notation. This is a link, right? And this is a really long Wikipedia link. And the picture is reverse Polish. So it's like known as postfix notion. Is a mathematical notion which operator follows their operands. So 3 plus 4 is written in this. Okay. Okay. So valid operator are plus, minus, multiple, and divide. And each operand may be an integer, so they are only integer, so it's okay. And the division between two integers should truncate towards zero. Truncate towards zero. So it's still an integer, right? So it is guaranteed that the given RPN reverse Polish notion expression is always valid. That means that the expression will always evaluate to a result, and there will not be any division by zero operation. So it's again, this is just to guarantee us that the input is always correct. We don't need to check whether the syntax of the input, whether or not if it's a R R or what RPN or not, or whether or not we got something that is divided by zero. So I think, yeah, which means we don't need to do error checking. And the constraint is the entire length is 10 to the 4. The token I is either, okay, so the operand, the value operand already mentioning here, right? And then the integer is in the range. Oh, the integer is small too, so not too big of the problem. So the token is 2, 1 plus, so 2 plus 1, right? Which is 3. So then 3, 3 multiple, so 3 times 3, which is 9. Okay, so it's written in this. And then 4, 13, 5, and divide. So it's 13 divided by 5, which is 2.6. So it's 2. So it's 2, right? And then 4, 2 plus is 6. Okay, so it's quite easy, I think. So you just go, 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 and find the operators, and then apply the operator on the previous two number, and then put the result back, and then keep going. So this is like a basic practice of a stack. right? So I think that's why I think, yeah, for a number 150 median question to us, it's a basic practice of a stack. Reasonable. I just don't know that, well, because those questions were used in the big tech companies interview. So it's probably just a warm up, just like, hey, solve this in 5 minutes and let's give you a harder question. Yeah, because this is too basic. Just to check if you know the stack. So we need a stack, right? So in Java, we can use stack of, so we need our input is a string and we probably need a stack of character, right? Or not character. Maybe a string, because we do have an integer and we do have operand. No, we probably only need numbers, because we never put the operand, we never put the operator into the stack. So we don't care about plus, divided, divide, and multiple or minus, right? We don't put those into the stack. So we only need an integer, because we only put integer into the stack. So stack, just to spell out so that we know this is a stack, and then new array stack. Okay, so now we have a stack. So we just traverse through the string token. So each of them are string. So for the integer, I think there is a Java to check whether it's integer or not, right? Or I don't. So I will probably like check whether or not they are operator first. So for each string, if like string, oh no, I didn't have the for loop. So for inti, or I don't even need the int. So for string s in tokens, and if s dot eqa equals to the operand plus, then let's do plus. And because it's already guaranteed that the input is always a valid reverse Polish notion, so when we got any operators, we are guaranteed that there are numbers in the stack already. So if so do I need to do it one by one? Like if this, so s the pull, no, this is a stack pop plus, or s the stack is stack, so stack the push, or I can push later. So let me just do integer cur equals 0, give an initial value. So I will just do cur equals to you pop and you pop, or else if I think there is just a lot of like copy and paste. If this is minus, do I do this? And then if it's a star, which means it's a multiple, then I pop hop and times it together. Do I need to care about overflow? No, the integer range is only 200 to negative 200. So I don't care about that. And also the last one, and we don't even need to care about divided by 0, right? But for the last one, we do need to care about which divided by which. So for this, the first pop is dividend. The first pop, the second pop is divider. So for this one, I guess I do need to care for, oh, I have too many like this. So the first pop, can I make it shorter? I don't know. I don't know a better way to make it elegant. So I will just save the first pop in here, and then my cur will equals to the second pop divided by cur, right? It's as short as possible, but I don't know if that is a readable style of coding. Let's do it for now. Yeah, I just don't think the naming of the variable and the way that I code it, it's not that meaningful, right? I put it into a cur, I pop again. Yeah. Anyway, maybe my coding style should be, yeah, I should improve my coding style. Okay, so now that I have the cur and the less is else, if the string is not operand, then it must be an integer, right? So else cur equals to integer dot parse int s. So now I have the cur and I need to put it back to the top of the stack, right? Stack. So stack dot push cur. Right? So I keep doing this, but it's not for, so because I need to keep doing this until the stack is null, right? So what should I do? So how to code this better? I mean, so I go through the tokens, or let's see. So I keep push it into the, oh, no. So for each one, if it's like, okay, so for each one, if it's a number I push, if it's a number I push, operand I pop to and push, and then now I have a number, so I pop them and push, and then I pop them, push. So I think that's it. I don't need to do the while stack is not null, right? Because it should be always null, because you can see that it will always end with operand. And because we know it's always valid, so for example, for this shorter one, when we reach two number and one operator, we pop 3 and put 1 back in, and then we don't need to go back to check the stack, right? So we just go forward with the token, and then we found operand, and then we will pop 2, and then we push that back. So no matter what, because we won't push an operand into the stack, so no matter what, the stack will end up with only one number. So the thing that we need to return is tack.pop, right? So I guess that's it. So it looks like we are correct for this one. So let me try the other two. So yeah, so I think this is a valid answer, but before we submit, we need to check the edge cases, right? The token length is at least 1, but because it's always valid, it's guaranteed to be valid. So if the token length is 1, it's guaranteed that it's a number. So we just return that number, right? So if it's 1, then we will read that 1 and then push that into the stack and then return that by popping it. So the edge case is okay. And then the other edge case is too hard to come up with an example. But for this, we need to just check our time complexity. And because we only check each string once, so our time complexity is just n. And our space complexity is probably also n, right? Yeah, so we might keep getting the number, and then all the operators are in the back of the stack or string or token, right? So we put all the number in, and then yeah. So it's 2 of 3 over 2 n. So it's O(n), right? I think. So the time complexity and space complexity won't be an issue for us for 10 to the 4. And the number range is small, so I guess we can submit. Wrong answer. Oh, I did it in the divide, but I didn't check that in the okay. Why should I only, yeah. So again, subtract. The first thing you pop is not the, yeah, you should keep that. So I need to do the same thing that I did with divide, which is this. I should check more. Yep. Now, do I submit again? Is there any other things I forgot? Probably not. Okay. Somehow I did it for the divide, but I forgot to do it for the subtract. Okay. Oh, hi Chris. So yeah, so I guess that's how much time do we, okay, Yeah, we spent like 20 minutes to do this only because I forgot to check those. So let's see if I don't think there's any other better solution, right? Another problem? Yeah, we can do another problem. Hey, but my browser, okay. Array for maximum sum. Okay, so let's do this. Yeah, so let me finish checking. Did I do something wrong? Reducing the list. Wow. Okay. I never thought of that. So, but using stack should be the official answer, right? I think. Yeah, using a stack, it should be the official answer. And I don't think there is any other in the discussion. Stack. Yeah, all of them are stack. Lambda expression. Okay, I don't know how to do that. Okay, so that's our daily question. Now let's do another one. Let me close the reverse polish notion. So it's 10:43. Wow, a lot of upvote. So yeah, which company? Let's check. Amazon. We just can't get rid of Amazon, right? Okay, so there are two hints. So let's read this together. This is provided by Chris. Okay, so 1043 partition array for maximum sum. Given an integer array ARR, partition the array into continuous continuous subarray of length at most k. So you got k as an input. After partitioning, each subarray has their value changed to become the maximum value of the subarray. Return the largest sum of the given array after partitioning. Test case are generated so that the answer fits to an integer, 32-bit integer. Okay. And our constraint is the array length is up to 500, and each number is 10 to the 9, between 0 and 10 to the 9, and the given k will between the length. Reasonable, right? So because we are going to do continuous subarray at most k, and k has to be a subarray, so it should be in the range. So let's see the example, see if I understand this correctly. So you have 3, and you want to return the largest sum after partitioning. So you change all those to 15 and change all those to 9. No, you change all those to okay. At a glance of it, I originally want to slide the window of k, but so this looks like a DP, but I might still need to use a sliding window to fix the DP. So my DP will be DP, for example, 1, 0, 1, 2, 3. DP3 will be the maximum sum ending here. So the next one will be either I put myself into another k, then the sum is previous sum plus myself, or I put myself with you with the previous one together. Then does this case miss something or anything is missed? So I think this is a dynamic programming. Although there's our hint, I'm not sure if I can do this. So because my value is only have relation with the previous one, or if I am in the same with you, then I will be the last one. So I will need to check what's the max value of that k. So maybe I can slide a window first to know each interval. What is the largest number, right? Have I done this before? I did once. 2019. Okay. Should I take a look at the hint? I think I have an idea how to do it, but I'm not sure. So for the beginning, I will slide a window of k. So I will maybe do an integer array of, how to call that? Not dp. Currently, it's not dp. I just want to know the max number within that range by sliding that window. So I will do like max s. They are all the max. Max in k. For it's a new like integer array of arr.length. I can type arr.length. So let me fill that out first. So for inti equals to 0, I less than arr.length. Do they declare? And then I increment. So what I'm gonna do is, no, I'm not gonna do this yet. So for a window is this, I will slide it. So I'm doing this just for myself, easier to understand. So for me, I will do to k first, to integer current equals to 0. So cur plus equals to arri. So by the end, I will have like the max in k of k minus 1 equals to the cur. Now, for anti-I, or maybe I can just do I. So if I do this I equals to 0, well, I'm just doing my coding style thing again. So I can probably do I don't know. So for that, I don't need to initiate this again, or do I? Is this better? I'm always thinking about my coding style. Why? So anyway, let's do this. So now I start with K, right? I smaller than ARR the length. I plus plus. So it's a sliding window. So cur or not cur, mark max in K of I. Oh, no, not max. Oh, my God. Max. I'm doing max, not sum. So it's like, let me initialize it with ARR1, 0, and I will be equals to 1, right? So then start from 1 until less than K. Max equals to math max of max. And hey, did I submit? Yeah, I did. Okay. ARR I. So I want to know the max of the interval. So then I assign that to K minus 1. So which means from 0 to K minus 1, for this first interval of K, I save the max in here. And then from there, they didn't say, okay, so how do I know? Oh. Oh. Okay, if I want to know the max of a sliding window, maybe the easiest way is using a priority queue. No. No way. So then what should I do? What's the easiest way to get the interval max? Hmm. I think doing a segment tree is probably too much because the K is the fixed interval. But how? I mean, do I do a tree map? Like mapping the number in the array and the count? So, okay, let me check the tree map. Can we get a max key? First entry, first key, return the lowest key. So if we have higher entry returns the key value mapping, that's a higher. Do we have a highest? First key is the lowest. So what's the opposite? First key, last key. Last key is the highest key. So I probably can do a key tree map. I don't know if that's too much. Okay, let's make sure my DP is first by reading the hint. DP, yeah. And keeps everything inbound. DP is the max of DPM plus max ij times j. Hold on, so what is, do I not need the interval max? And yeah, so I guess my thinking is correct. Maybe. So yeah, I will probably just get a tree map. Tree map of from integer to, hold on, this is a median. Do we really need to use tree map? Anyway, integer to integer. And t map equals to a new tree map. And then so from 1 to k, if tmap dot contains, the key is ARRI. So if it's not contain, I will edit tmap dot put ARRI 0, and then I will do, oh, I probably don't need this. I will just do like tmap dot put tmap dot get or default. So I get ARRI, and let's default to 0, and then let's +1, and the put should have the key to ARRI. So for each one, I count them and put them into a tree map. And then the maps in K will be tmap dot last key. And now let's slide the window. So from I equals to k until the end of the array, our tmap dot so I want to decrease that. Tmap dot get the put ARR I minus K, and then tmap dot get ARR the I minus K. So you get the number, you decrease by 1, right? But and I will add ARR. So the current one is I, and we have tmap dot get or default, get a default ARR I. So if that it doesn't exist, then we use 0 and then we plus 1, right? So after doing this too, we need to check if this one is 0. If it's 0, then we like remove it. So if tmap.get ARR I minus K equals to 0. So there should be a remove, right? tmap.remove ARR I minus K. So after we remove, we make this equals to tmap.last key. So when we remove, is it remove? It just remove, right? Remove the mapping for this key. Yeah, it's just removed. So it should be okay. So what I'm doing is I'm selecting the K window and remember the next within this K range. Okay. So now let's define our DP. So let's define an integer array of DP equals to new integer. So what's the size? ARR.length. So what I'm going to do is I want to know the maximum value or the maximum sum ending at that point. And what we are going to return, we are going to return DP, the last one, right? So this is what we are going to return. And then what is our DP? So our DP is defined by, so what's our initial value? So initial value, so again, this DP will have like K. Oh, okay, so K is always valid, right? So again, I will have this again. No, I equals to 0. So what I'm going to do is I will have dp 0 equals to dp ARR 0. and then I will sum them. dpi equals to dpi minus 1 plus arri. So when I reach k minus 1, it's the sum of that array, right? So is that our initial value? Hold on. So oh no, I don't need sum, right? So our first one is what am I doing? So we don't even need the first one. With our first one is the k minus 1, right? So our k minus 1 is just max k minus 1 times k, because that's the first k interval, the maximum number times k. So dp is defined. Let me comment. dpi means the maximum sum of the array array ending in I. My cat is trying to, okay, go. Goodbye. So then our dp could be, so I don't need this. So what I'm going to do is I equals to k, I less than arr.length, I plus plus. So dpk will be math.max so it will be the sum of your previous one. Let me see, dp I minus 1 plus myself, or dp I minus, or we are in the same level, so I minus k plus max in k of my current value, which is I, times k. So that's my dp function. So my current maximum value is the max of first I myself with the previous one ending, right? So if I myself is in another block, then it's my previous value ending, the max value ending in my previous position plus myself. That's the sum. Or I have the, if I am counting as the last one of this k interval, then that's the dp of the I minus k plus the maximum value until my point, and then times k. Okay, my cat is going crazy. Come on, come on. Sit. Sleep. Lay down. Oh, come on. Okay, sleep. So then we will return the last one. Let me run the test case. Line 12. Put getter default. Line 11. Null pointer. So line 11, null pointer. Oh, so I might, how can I not getting it? I should always get it, right? Because it's, so I have a null pointer, but how? I want to put this -1, and this should always be there already because I did this first. Right, I-1. Wait, is that because I might remove it? Hold on, the logic. So I get this is within this, right? Okay. Let me run this by head. Because, okay, somehow do I print it out? Do I want to print it out? I don't want to print it out. When I put it, I won't have a null exception. It is when I try to get it. I know if I do a get or default, it will be okay, but how could I remove something that does not exist? I have a K, I add everything into the T map, and I increase by 1, so I want to remove the previous one. Oh, because I didn't put 0, right? Because I start from 1. Okay, okay. So my T map, I should also put, oh my God. That's my coding style. Why I initialize it with 1? Do I have a clear way? Oh, that's because I was thinking about max. Okay. So I should remove that, and let's start with 0. So if we start with 0, then it's probably not a problem. Okay, this works. And then do we have other test case in here? Wrong answer. For the second one, we got the wrong answer. Okay, let's see. My answer is 76, but it's not the max. So for now, I will assume my way of getting the max is correct, but my DP is probably wrong. Because I remember I saw the hint and my transition function is way different compared to theirs. So there, for J from 1 to K, DPI is maximum of DP. So they only do this part. They only do this part. So why do you not this part though? So why do I need to? Yeah, why do I need to not to compare if I have a value? Because I want to maximize the value, right? But by doing that, mine is actually less better. So let me change to their solution. So their solution is DPI is just simply this. And this won't even give me the correct answer. Okay. Yeah, so where is my transition number value wrong? Okay, I got it. So my first few DP is wrong. So I probably need to update my max I in here. No, not here. After we insert that into the map, so I will need to have each one of them have the max I. So max I is this. And then so our dp for the first I guess this one is wrong. So for the first for I equals to 0, I smaller than k, I plus plus, and then now I can delete this. So for the first k, my dp is just equals to max in k of I times I plus 1. That's the number of, right? I think so. And then I can do the transition function, and then I can return this. Okay. Still wrong. How? So for the first less than k, every one of them, their max value is this. Oh, okay. Yeah, and I plus 1, because when we reach k minus 1 is k. And then start from k, it's this. Again, my dp function is different than theirs. I'm still wondering why. Is that the reason why? So I guess this is their dp function. No, it's wrong. Okay, so I really don't know. So is there any other possibility for the dp? Yeah, let me take a look at the hint again. So why their dp is different? They only consider this part, which is this part. Why nobody need to care about this part? And why after I remove it, my answer is wrong for the first one? Each subarray has their value change to become the maximum value of that subarray. So for this one, yeah, so it's 1, the maximum 1, the maximum 4, the maximum 4, the maximum 5. And from here, my first transition function is either dp minus 1 plus this. So it's 5 plus, oh. So my dp will be 1 and 8. And yeah, let me check again my max. My max logic should be correct. do it one by one, right? So I add that into, and I check the max one, and then I get that. Oh, I don't need this, right? Because I already did it in here. But still, that doesn't change the. And then I started from here. I removed one, and then put one. And if this is 0, I remove that. And then after remove that, I assign the maximum value. Okay. So still, it's my DP that has problem. So I calculate the initial value of the first K element. So they are the max so far times element so far. So if I do that, so let me check for this. For this, my max I will be, so for 1, 4, 4, 5. Seven, right? The K is 4, 7. And here we still have 7. And here we have 6. And then here we have 9. We again have 9. We again have 9. So our DP so our DP will be, for the first K, it will be 1. And then now the maximum is 4. 4 times 2 is 8. And then now the maximum is still 4. 4 times 3 is 12. And then now we have 5. 5 times 4 is 20. Right? And then that's this loop. And then we start this loop. So for this one, the max is either 20 plus 7 compared to 7 times 4 plus dp1 is 1, right? So 29. Right, so because that's from here. I have 7 times 4, which cover this 4, and then with dpi minus k, I is 5, minus 4 is 1. Hold on, I minus k, I is k, yeah, I minus k is 0, so 29. And in here, it's still better to, it's either max of 29. 29 is from here, right? So 29 plus 7. So it's either 29 is 36 or that. So it's this, which is dp 8. So a plus 20a, which is 36. So they are both 36. So anyway, this one will be 36. And it's either 36 plus 7, which is 43, or dpi minus k, so it's this 12 plus 20a, which is 40. So in that case, I should get this, and it should be bigger than this. Is that true? So now this one is bigger. So let's see. So if this is 48, 48, 28, and 12, 40. But if I do this, which is 29 plus 3 is 32. So I am wrong. Oh, ARRI, ARRI. So yeah. So it's 40. Yeah, so I don't see anything wrong with my BP transition function, but somehow it's wrong. So I'm going to see the discussion. Yeah. So 5 more minutes. I don't see anything wrong, but the answer is wrong. wait. So I minus 1. So dpi is the a minus 1 to a minus j. Okay, let me read. Yeah, I don't see why it is wrong. Oh, you need to count each one of them? Oh, yeah. Oh, so my idea is wrong. Okay, so it's the maximum of this. So you actually, so this is just two edge cases, right? So you actually need to count everything in between. So my max in K will not be working because you have to check from this point and maybe backward for 2 or 3 or 4, but mine is always 4, so mine is not working. So do you just do an n square to check max every time that you need a max? Or you just directly use segment tree to check the max? Okay, let me see the discussion. OK space dp. To get di, we will try to change k time is n times k. So your dpi is the maximum sum we get from the previous. So I is actually means length. We will try to change k last number separately. Okay, so you from 1 to n, and your dp0 is 0, because if length 0 is 0. So your current max, your best is, so from k to from 1 to k, and I minus k need to be larger than 0. So is this a smaller k and a larger k? Hold on. Oh my god, it's so hard to read. So smaller k, lowercase a is equal to 0 to the capitalized k. And then you check the current max is current max. And yeah, you do it linearly. So every time you go back k and check which is the max again, and then your best. Yeah, so you don't need to do the segment 3. So you just go through again and again and again and again. to check. So this is how I'm confusing though. So how do you make sure that m times k is a good solution? Because the ARR length will be less than 500, and then k, so k will be less than 500. So you don't think this will be an issue because you have 500 times 500 is still small enough. Okay, so that's why you don't need to do a segment tree to fast calculate the maximum value between two intervals. You just go through them every time. And then when you increase I, although they are similar number, but you go through them again to check the max. Okay, so I am complicating this. Oh my god. Okay, so now that I know the result, solution, can I do it myself without watching it? I doubt it. Okay. So the last time when I did it, I probably watched the solution, and now I forgot again. So although I know, okay. So first, I don't need this anymore because I originally think that we only need to do, and then we don't need a tree map anymore. So we just need to go through the entire thing. So let's define a DP. Okay, so now this DP is not defined by the maximum value that you can get at that point I. It's actually defined by the length I. So now you need to plus 1. And this also confused me. When do I use the length and when do I use the... I know most of the time we use the length to define the DP, but why? Is that because it's easier that we have DP0 as 0? I don't know. Okay, then I probably don't need to separate that anymore. And then, so you don't need to start with 0 because you start with the length 1, right? And your length is k, which is a smaller k, and you plus plus. And then for each length, the transition function will be so dp I. Okay, what's the first k? Okay, now I want to see the solution again because I always separate between the first k and the one that's after k, just like this. So, but I remember Lee215 didn't separate that. So how do you not separate that but write it elegantly? So your DPI for that length 1. Yeah, okay, hold on, I want to check. So why do you not need to use the, yeah, how do you DPI minus K? Oh, because you do this. Oh. Yeah, oh. This I can't do. I'm not that smart. you have a current max to keep checking the current max, and then you have the best solution to keep tracking the current solution. Oh, okay, DP is hard. Okay, so I need a current max. What number do I initialize it? There are so many details I don't know. If we are checking the max, we can use 0, right? I think. And then max sum. And then we go back k. So this is the current length, and then so we go back k. So for int j equals 2, so you go back 1. So this is j is actually the length of the last segment, right? So the length of the last segment could be from 1, which contains the ith, to which number? To k, because that's the length of the last segment. But you also, like V215 did, you also want to check if it will be out of bound. So you want, let's not check that first. So let's do this. So j++. So let's do the transition function first. So you will have the current max. And which element you get? ARR. I minus j. Is that the one that you get? So when the element is, when the length is 1, your current one is the I minus 1. Okay, yeah. And then your max sum will be math, the max sum compared to current max times, so how many items you have right now with the current max? J, right? So times j. Now we need to make sure this will be larger than equal to 0. Wow, there's so many details. And then after we do this, we know that your DPI, you can assign it to the cur max. And then you return this. No way, it looks shorter. Really? So this is not K, AR, the length. Wrong answer. Okay, so where is wrong? Maybe my initial value? Oh, hold on. So your max sum is this or cur max times J plus what? Plus dp I minus J. Hold on, still wrong. Oh, I'm so confused. Okay. Ah. Oh, God. Wait, any edge cases? What if we only have one? And what if 0? Okay. We could have 0, right? Okay. Oh, oh my God. It is so hard. So I'm probably thinking too much because I think to find the local max, we probably want to use segment tree, but we don't. The problem is, even if we have segment tree which can get the interval max quickly, we still need to do this dp function, right? So we still need to run through this for loop again, no matter what. So what's the benefit of using a segment tree to find the interval max really quickly? There's no benefit, right? Because no matter what, we need to go through this for loop. Oh my God, my cat. We need to go through the for loop anyways for the dp function. That's why we don't need to think too much about how to get the max value really quick. we just need to do this every time, one by one. So other than Lead 1215's beautiful solution, is there any other like solution for a regular person like me? Shouldn't this problem come under DP instead of graph? Okay, so it's just complaining about wrong category. Java, visualize the pattern. Yeah. Yeah, so actually you can still define it as the index, not the length. So I guess people can define it differently but still get the same result, right? So the way that but if you define it as the index, this function I need to think more. And then also you don't get the benefit of only checking this, and you can avoid something like this. Yeah, because now that you change the DP definition to use the index instead of length, now these two index become different. The index for the current max is I minus k plus 1, but the DP index that use is I minus k. So this is more of a normal person like me will think of, because I wouldn't notice that Lee215 is doing something that such elegantly that okay, let me get his solution again. Yeah, his solution is here. Okay. So the difference is that by defining the DP as a function of the length, you can beautifully get the current max using this index, and also the DP function using this index. So then in your for loop, you only need to check this, and then this DP function will work, will not go out of bound, right? But for a normal person like me, originally want to define DP as the index, a function of the index, not the length, then I will encounter this. Although I put this check in the for loop so that this will not go out of bound, which is less than 0, but because the DP function still use I minus k, I do need to check again if this is out of bound. So, and for someone like me, I probably don't know to put this into the for loop. I will do the same, how to call this function, question mark and colon. I forgot the name of this. I will probably do this again in here. So make the entire thing look like more complicated just because I need to check the out of bounds. But somehow, just like Lee215, somehow he realized that if you define this with a function of length, then you will magically have these two index the same, and then you will magically only need to put that into the for loop checking, and don't need to use this to check the out of bound condition. Anyway, I don't think this is a question for a normal person like me. I can't do this. Like, if I didn't practice this again and again and again and again, I'm guaranteed not be able to do this in an interview, because there are too many little stuff that you need to notice in order to make the entire thing really elegant. I don't have that kind of ability, I think. Okay. Let's check few more and then I will end today's string. So another Java. Yes, another Java, and the memo is their DP. And they also use index instead of. Then how do you check the out of bound condition though? Oh, you just use if? No. Yeah, how do you guarantee you are not oh, you're not going out of bound is because like he is doing the same thing again with me. I will deal with the first K and then do the another from K to the end. So this will be more intuitive for me because I don't need to like deal with the out of bound condition, right? So that's why you don't need to check if it will be out of bound because your I start with K in here and then it will be guaranteed larger than 0. Okay. Yeah, this one is also make more sense to me compared to Lee215, but yeah, Lee215 being Lee215 is not somebody else can mimic. Yeah. So this is longer, but this is really make more sense to me. I will always just, even for a sliding window, I will always do from 1 to the window size and then from that point to the end of the array because it will be easier for me to not needing to check the out of bound condition in both cases. Yeah. Okay. I think I learned something because I think I know what I can do and what I used to do. I used to do this and it's more complicated. And there's so much room for me to like make mistakes and then never come up with a solution like this. So yeah, thank you, Chris, for introduce me this question. Although they think it's medium, they said it's medium, but for me it's a little bit between medium and hard, because there are so many details. And if you do it one of the detail wrong, it's also hard to debug for me because it's a DP. So even for an array this long, it's already hard for me to debug. So yeah, thank you, Chris. And we did another medium question today, other than the daily question. So anyway, I think I learned something, and I hope you also learned something from today's stream. And it's already late, so I hope you have a good night. I will go to sleep, and I will see you tomorrow for another LeetCode daily question. Although it's already come out, I don't want to look what it is. We'll take a look tomorrow, okay? Okay, thank you for watching. Bye-bye.